Okay, I started recording. So Zahir and Nagarjuna, if I forgot to record, please remind me. I tend to forget a lot. So we'll start with the actual descriptive statistics. Those are very simple concepts. You might know most of them, but so I can go quickly. But if in case, okay, let me tell central tendency. So in case you find something difficult or you're not able to understand things, some of things, please stop me so that I can go slow down. I can slow down at that point. So whichever I think you might know, I'll go fast. So let me start with the central tendency. I introduced this concept initially, but I have not told anything about it properly. So for central tendency, actually there are three concepts which are very simple. One is mean, the other is median, last one is mode. So I guess most of you might know all of this, but I'll just introduce it so that it helps in future as well. Some of the things like standard deviation, you think you know, but you don't know some of the things. So standard deviation also you don't know as of now, because there are some other things that I have to teach about that.
Sandeep, you mentioned average as part of
Yes.
mean as part of inferential statistics. Here using
Yeah, I tend to use both a little bit interchangeably, because that's how I was taught. But it's fine.
Okay.
So in a way, you'll recognize which is inferential and which is descriptive.
Right, based on what underlying
Yes,
population.
underlying what is that? The basis for what I am talking about, you'll tend to realize things. But unfortunately, even I was used to average and mean as separate entities.
Yeah.
But you can correct me. I'll correct it because I got used to using it interchangeably. So average, it's very simple. So it's simply represented by x bar equal to sum of the values by number of the values. So as simple as that. But I'm going to introduce a little bit of notation here, which will be using in future as well. That's why I'm going to use some notation, which is sigma. So throughout this entire course, you will see this sigma notation. Sigma means sum of values. So let's say I have x1, x2, x3, x4. So we have 4 values, let's say. So if I want to do a sum of all these things, which means I'm going to do x1 plus x2 plus x3 plus x4. I can write it as using sigma notation. I can write sigma xi, I running from 1 to 4. This is the notation I wanted to introduce. So this I can actually, most of the times I will not write I running from 1 to 4, and also the I itself, I'll just keep it as sigma I, sigma x. So this is notation I am going to use going forward every time. So for this, I am saying sum of the values by number of values. I can just use sigma notation, sigma x by n. So are you clear about this notation?
Yeah.
It's a very simple notation, but in case you are not confident about the mathematics part. So let's call it as our, okay, let's call it a central tendency. That is good. Yeah. Central tendency 1. So again, central tendency median. So median is also simple again. Median is the middle value after sorting. So for example, let's take 1, 5, 7, 9, 11. These are the odd numbers. I'm just taking odd numbers. First 5 numbers. Oh, I removed 3. Okay, that's fine. So I'm going to call the middle element, because this is already sorted, the middle element as the median. So median equal to 7. And I already introduced percentiles. I said 50th percentile is median. So that is also there. 50th percentile is nothing but median. That's all about median. The only thing about mean versus median is, if there is sudden large values, which means outliers, or sudden small values, the outlier is going to affect average a lot. But median never gets influenced. Let's say instead of 11, now let me take another example. Okay, let's take the same example with some differences. So the same example, but let's say incorrectly I assumed 11 as 100. So in this case, so there is some data collection issue, but even then the median will not get changed. Median equal to 7 again. But let's say we want average for this. Okay. So let's not use our brains, we'll use Excel. So 1, 5, 7, 9, 11. So the average here is going to be 6.6. And the same thing, if I change one value, it's going to be 24. There is a lot of change suddenly because of one value. So median is not going to get influenced by outliers. So not influenced by outliers. Median is not at all influenced by outliers, but mean is going to get influenced by outliers. That is the only difference why we should go to median whenever there are too many outliers. If there are few outliers, generally we'll take box plot, remove the outlier, and then do our analysis. And then finally mode. Mode is just frequently occurring item. So let's take an example of having colors. Let's say we have a box of colored balls, and the colored balls, we are just keeping the colors as a list. Let's say there is a red ball, blue ball, and again there is a red ball and red ball again, then there is a blue. So what we do with mode is like we just compute how many times each colored ball is occurring, and then output what is the most frequently occurring item. So in this case, mode is just red. So if you see, mode can be just used for even categorical data. I mentioned categorical data, right, which is nothing but a textual kind of data. So red, blue, green, Hindu, Muslim, Sikh, Christian, all these are categorical data. So mode can be also applied for categorical data. Also, let's say you have some data set like this 1, 2, 2, 1, 1, 2, 2. So in this case, the most occurring item is 2, which means we can also use this mode for numerical data also. But the only thing is, what happens, another example 3. What happens when there is no frequently item in the list itself? 1, 2, 3, 4, 5. So each one is occurring only once, and there is no frequent item here. So in this case, no mode. So there cannot be cases where there is no mean or no median, but no mode can happen actually. So when nothing is frequent and each one is occurring only once, there is no mode. So this is about the central tendency. So let me talk about this as, so what central tendency looks for is what is the central item, either it is mean, median or mode. It's going to define the central characteristic of the data. So in in descriptive statistics, there are 3 major branches. So one is central tendency, another is dispersion, the third one is shape. So for central tendency, we already covered all of them: mean, median, mode. Here you also have 3: range, IQR, which is interquartile range, we already learned about it, standard deviation. Standard deviation. And in the shape of the data, you'll have 2: kurtosis and skewness. So in all of them, generally we learn all of this, but kurtosis and skewness will not learn in detail. It's out of the scope for us and it's not needed much. given all the machine learning techniques that we will be learning and all, curtices and skewness are something that you don't need much. Only skewness you need, but curtices is something it's not needed for you. So that's how the descriptive statistics looks like. Now we covered central tendency. We'll cover dispersion and then the other one as well. So this is how the descriptive statistics looks like. So any questions till now on whether I mean how we are going to cover the descriptive statistics is one thing, and the second thing is the central tendency that I covered. If you have any questions on that.
Sandeep, just one question. So comparing descriptive and inferential statistics, the trend of the industry is it's leaning more towards inferential statistics, right?
Now you need to know descriptive as well. Without descriptive, for example, sample standard deviation, whatever I am covering here.
Yeah.
So for sample standard deviation, unless you can compute sample standard deviation, you cannot do any inferential statistics. Unless you compute the mean, you cannot do any inferential statistics. This is the basis for inferential.
Okay.
So without this knowledge, you will never know what is inferential.
Okay. So basically, do you have to do descriptive statistics before you move to inferential statistics?
Yes, obviously, yes. Without this knowledge, you will not learn. I mean, without sample standard deviation and sample mean, you are not going to do anything on in inferential.
No, I'm not talking about the knowledge part, but in terms of getting to the calculation or the estimation,
Mm-hmm.
you have to go through the descriptive statistics, or it can be done independently.
So thing is, yeah, you have to. The final aim is to learn inferential statistics, but the stepping stone is always descriptive. Even in inferential, you'll use a lot of descriptive statistics.
Oh, okay. No, my question is not about the learning path. I understand that we are going to look at descriptive and eventually invoke some of the knowledge in inferential. But what I'm asking is, you have to say, for example, compute and calculate some of the statistics on the descriptive part before you get to the inferential part.
Okay, your question is, at the end, are we going to calculate only inferential or even the descriptive?
Yeah.
The answer is we will do both. Even at the even after building the model, we will need some of the inferential statistics, some of the descriptive statistics.
Okay.
So there is something called parametric and non-parametric methods. So most of the higher level models, machine learning models, they tend towards non-parametric. So when you say non-parametric, you cannot compute inferential statistics. So there are some other techniques which are parametric, which means you can compute inferential statistics. So this is a mix of both. Sometimes you do descriptive, sometimes you do inferential. It depends on the model. So sometimes you will be using a very simple model. In that case, you are going to use inferential.
Okay.
The more, so for example, neural network is there. Neural network never works on inferential statistics. The reason is it's very, very complicated. So it never works on inferential.
Okay.
So we'll get to that, because if we jump, you'll not be able to, I mean, I'll be able to answer, but you'll not be able to grasp the real concept.
I mean, I was just a relationship between descriptive and inferential. That's what.
Yeah, you'll be using. So thing is, you'll be using both.
Okay.
When to use what is the question. That question you'll will not get answer today.
Okay.
Even if you answer, you'll not understand. That's the problem.
Yeah.
Okay, but anyway, but you're able to understand what is descriptive statistics and what we are going to cover in the entire session of descriptive, right?
Yeah.
So let's go to dispersion. I don't know what is the spelling. It's this one. Yeah. Okay, now we're going to dispersion. So what is dispersion? Let me define that. Central tendency is just central characteristic. So that's why we always go for mean median mode, which is the central characteristic of the data. And dispersion is like how much it is deviated from the center. So we define center, and we also define how much it is deviating from the center. These are the two different concepts, but both of them always go hand in hand. When you define mean, you have to define standard deviation. Only when you define both of them, you're defining the entire data. That's how it is. I'll give an example why dispersion is needed as well once we complete the dispersion. So dispersion is, so by the way, I don't give textbook definitions and all, which is not needed. Whatever definitions I give, it is purely mine. So whenever I give some definition, don't think that this is how it is. It is more like I try to make you understand in a very simple way. I don't try to give complicated definitions and then say this is how statistics is. I try to simplify things and feed it to you. So how much the data is distributed, or instead of distributed, I will say deviated. Deviates from the center. The reason I am not using distributed is because there is a concept called distributions, and again you might get confused. So what I'm saying is how much the data is deviated from the center. How much the data is deviated. Sorry, this is not deviates. Date. So this is what I wanted to find out, how much the data is deviated from the center. It could be very less. In that case, the data will be very closer to mean, or it could be very too much. So in that case, the data is too much deviated from the center, which means the data is spread across the, so it is almost like, let's say there is a city, let's say New York, where there is a city center, which could be like Wall Street or some area, whatever it could be. It could be some X area. So if the data is if the city is distributed, it means that people are living sparsely across the center, across the city center. So they are spread across. So in that case, what happens is, so there is something called what is that? Population density. So the population density, if it is less in some city, it means that they are scattered. People are scattered far away. But in some cases, people are not that much scattered. People are like living very closely to the center of the city. So both are very different. So in the first case, when people are very scattered from the city center, it means that your traffic and all those things are in control. All the city management issues are very less. But in the other case, where the people are very closely located across the center, there will be more problems. the city management will become very difficult. There will be so much of traffic problems. There will be so much of water scarcity problems. Maybe more pollution. All those things come when city is very closely related. I mean, closely situated. So people are sitting very nearby to each other, and there will be a lot of problems in the city. What is it? In the way people organize their homes and houses and all. So if the city is scattered, you can have a very big mansion and all. But if the city is very close by, I mean, people are staying close by, there will be very little space for people to live in a society or something. So that's how dispersion is very important. I think my analogy is good. If it is confusing, I can explain again. But my analogy is like the data related. I mean, data sitting very close by to the mean or median is very much different than data scattered across. That's why dispersion is very important. So you should always talk about the city center and also how much the city is spread across. Is it very close by or very far away? Both will define different characteristics of the data. So let me talk about dispersion. There are three things. I already mentioned that. So the first thing is range. Range is very simple. Maximum of the data values minus minimum of the data values. It's very simple. Max minus min is the range. So for example, if you have a data of 4, 5, 9, 3, 15, I intentionally made it unsorted. So the minimum is 3 and the maximum is 15. So the range here is 12. So that is one metric that you can use for dispersion, which is rarely used. It's not really that much used. The second one is IQR. So for this, I already defined this as Q3 minus Q1. So this is the IQR. I already described, so I'm not giving example for this because you know the complexity in calculating that. If you need, I will give, not an issue. The third one is standard deviation. Now, standard deviation actually captures the exact meaning of whatever it is description of the dispersion. So I gave the dispersion as how much the data is deviated from the center. Right? So the standard deviation tries to capture the exact meaning. Its formula also is very close by to the definition. So the thing is, there are some issues with creating the standard deviation. I should mention those before I finally give the formula. So the thing is, so standard deviation is how much you are deviating from the center, right? So let's say I have x1, x2, x3, x4. We have 4 variables, let's say. And x bar is the average, which means sample average. Now, when I says how much your data is deviating from the center, I can do like this. I can do x1 minus x bar. So what I'm essentially doing is I'm taking each data point, subtracting from the average. That I am considering as how much it is deviated from the center. Each point I'm checking how much it is deviating from the center. That's what is my definition of dispersion, and it is actually standard deviation that is capturing this meaning. So I can do like this. I can do x1 minus x bar and x2 minus x bar, x3 minus x bar, x4 minus x bar. So I can try to calculate each and every point how much it is deviating from the center. That way, overall I'll get how much my entire data is deviating from the center. So this I can use it, I mean, I can name it as sigma x minus x bar. So, or I can do, I already introduced just now this sigma notation. If you are not able to understand, I can explain again. I am giving sigma I equal to 1 to 4 xi minus x bar. So sigma means sum. So it will become x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar, all of them summed together. That's how the standard deviation comes into picture. I mean, sorry, this formula comes into picture. So now the problem is, okay, I can also mention it as, like I said, I don't use I notation because it is not always easy to find out. And we are not really in academics. So I'll just use it as x minus sigma x minus x bar, simply. So it turns out that this sigma x minus x bar will always be 0. I'll show you the simulation of it. Sigma x minus x bar will always be 0. The reason is, intuitively I can explain. X bar will always be at the middle of these values, all of these values, and some of them will lie at equidistance from the left side and right side. When I say left side and right side, some of them will be -2, let's say. Others will compensate and say it is +2. All of them will nullify each other, and finally what happens is sigma x minus x bar will always become 0. I'll tell you, I'll show you an example where we already calculated the samples, right? So I'll remove all these samples. I'll keep only one sample, because now that you know what is a variable and constant. So I am taking one sample. I'm naming it as sample. That's it. Now I am saying sigma x minus x bar is 0, but since it is difficult to prove it, I am trying to prove it by simulation. I'm calculating the x bar, which is the average from F2 to F101. So I got the average. Now what I wanted to do is so this is x bar. So x minus x bar I will calculate. X is this one, x bar is this one. I'm going to subtract each of them. X minus x bar. So I got x minus x bar for this value. I need x minus x bar for all the values, all the 100 values. Okay, it seems like I have not removed the entire thing. So I need for each of the element, I want x minus x bar. So I can drag it and Excel will calculate for each of them. That's the power of Excel.
I think you'll have to put the $sign there, the formula.
Sorry, yeah, you're right. Okay. Now we got x minus x bar. What we need is a sum of all the x minus x bars. That is sigma x minus x bar. So what I do is I'll do a sum of k2 to k100, k101, sorry. It's going to be 0. Okay. So it always happens. It's not just once. I can take 100 samples, all the 100 samples. If I take sigma x minus x bar, it's going to be 0. Now my definition of dispersion, which I am saying how much the data is deviating from the center. So it's not working somehow. I mean, ideally it should be working, but it's not working as is. So that's why in standard deviation, you always see the dispersion as, you'll try to characterize the dispersion using sigma x minus x bar square. So what it means is the square is inside. So what it means is, the reason for doing this square term is, if you see here, some of them is positive, these are positive, these are negative. So there are some of the values that are negative, some of them are positive, and finally if you do a sum of all these things, you're going to get a 0, because all the negative numbers are going to nullify the positive numbers. So finally your deviation is going to be 0 only. So in that cases, because it happens always, what you want to do is you want to calculate the square of the number so that all these negatives will become positive, and finally your deviation is actually some value, it's not 0. So to make that nullification, to remove that nullification of positive and negative numbers, we'll try to use square. That is one thing. There's only one part of the standard deviation. We are not yet completing it. So, but until now you are clear how the sigma x minus x bar we want to use. Why do we want to use sigma x minus x bar? That is one thing. If we want to use x minus x bar, why do we want to use square of it? If you are okay with it, then we'll continue with degrees of freedom.
I'm okay.
Okay. So let's now start with degrees of freedom. This is where the fun starts. It's going to be tough. Yeah. But I'm going to make it easy. Don't worry. This concept, even some of the PhD students, they don't understand, but I'll try to make you understand. In fact, you will understand. No need to worry about it. So I'm going to talk about degrees of freedom now. So what is degrees of freedom? Degrees of freedom is how many variables you are free to modify. Free to select. It's very vague, but I'll give you the definition properly. How many variables are free to change? This is the degrees of freedom. This is what we are going to do. So let's take some cases and identify how many degrees of freedom. That way we'll understand it quickly. If I give you a big definition, you'll never understand this. So let's take one example where x plus y equal to 10. I want to satisfy this equation and I want to find what is the degrees of freedom for this. Degrees of freedom I can denote by df. So one of you, I think Nagarjuna, if you are there.
Yes, Andy.
Yeah, Nagarjuna. So I have two variables. This is my case one for degrees of freedom. So I have two variables, x and y, and I have one condition. Okay. The condition is x plus y should become 10. So let's, you can give some number, x can be anything. You can give some x value.
Should I give now?
Yeah, you can give now. Yeah.
So 6.
X equal to 6 you said, right?
Yeah.
So in this case what we did, we chose one value. We chose x equal to 6. In that case, can you choose any other value of y? Can you choose one value of y?
So let's have the other one also as 6.
But in this case, so you're saying y equal to 6, right?
Yeah.
But can you choose this 6, y equal to 6, at the same time satisfy this value, this condition?
No, we can't satisfy it.
We can't satisfy it.
Yeah.
So can you choose again by satisfying that?
So 4 is the only option that we have.
Which
6 plus
means
4.
what does it mean? That means that after choosing x, I don't have a choice for y.
Yeah.
I can also do reverse. I can choose y. In that case, x will be fixed. So in this case, so what I was telling is, what I'm trying to tell is, degrees of freedom is always number of variables that you are free to change. So in this case, when I have x plus y equal to 10 as a condition, I have only one variable to change. So my degrees of freedom will become 1. Okay. So let's take another example. Case 2.
In that case, degrees of freedom will be 1
Yes,
or
yes, degrees
0.
of freedom.
I mean,
In this case,
so we can change only, we can interchange. So that means it is only 1.
only one.
Okay.
You can only choose one variable at a time. That's it.
Okay. Okay.
Second variable you are not free to change. So let's take another example. X plus y plus z equal to 15. In this case, let's choose x and y. Let's take x as, you can tell, yeah.
Yeah, we can take a 5.
X equal to 5 and y
7.
7. So once you take x and y, z will be fixed to
3.
3. So in this case again, you have only 2 degrees of freedom. So the degrees of freedom here will be 2. Clear about it?
Yeah.
Now I'll give a little bit complicated. This will be our final case. X plus y plus z equal to, we'll take the same example 15. But I have another condition. So which is y plus z equal to 10. Can you choose x here?
X may be 5.
But you are not choosing here. X is 5, that's it.
Yeah.
Based on these conditions, x is always 5. So you cannot choose x is 5.
Yeah.
So you can only choose y or z.
Right.
Let's say y equal to 5 or y equal to 6, let's say. Then z equal to 4 and x is anyway fixed to 5. Right?
Yeah.
So in this case, degrees of freedom is just 1. So what I'm trying to do now is I'm trying to find out a formula, a generic formula that works with all these kind of cases. So what I say is degrees of freedom equal to n minus c, where n is number of variables, c is number of conditions. So now let's see if this works or not. So here n is equal to 2.
Yeah.
N equal to 2. Conditions is only 1. X plus y equal to 10. So degrees of freedom is n minus c, which is 2 minus 1 equal to 1. This works. And here also we can try. N equal to 3, c equal to 1. Now degrees of freedom is 3 minus 1, which is 2, which is correct.
Yeah.
And here also we can do n equal to 3 and c equal to 2 here, because we have two conditions here, these two.
Yeah.
So in this case, degrees of freedom is
So, as
3
you showed
minus.
practically in case 1 and case 2, like we have only two condition, two things that we can take, 5 and I mean X
7.
we can take and Y we cannot. It was we can't change it, right?
Yes, yes, we can't
So
change it.
how,
We can choose it
yeah,
ourselves.
yeah. How can we? How can that can be justified in case 3? In that mode, like if we have X plus Y plus Z is 15 and Y plus Z is 10.
So in this
Uh,
case, so when you say y plus z itself is 10, you're
yeah.
saying x plus y plus z, which is y plus z itself is 10, equal to 15. It means that before even you try to choose, x is always fixed, already
Yeah.
fixed. So the only thing you have to do is y plus z equal to 10. Only this condition you have to see if you can add any value to it. I mean, choose any value to it.
Okay.
So either you can choose y or either you can choose z, but you cannot choose both.
Mm-hmm.
So
Okay.
you have only two variables, out of which one variable is chosen, and the third variable, which is x, is already fixed because of these two conditions. So
Okay.
there is no way that you can choose more than one variable.
Okay.
Got it?
Yeah. So the variable that we are choosing is like in Y and Z. That's it. In the case 3.
Yes, that's it. In case 3, we are only choosing y or z. X
Okay.
is by default, it is fixed based on these two conditions.
Mm-hmm.
So
Yeah.
you should understand this degrees of freedom very well, because degrees of freedom is going to be used everywhere in future, almost everywhere. At least you'll find it in, if you are having 120 hours of class, you'll at least see in 80 hours of class. That's how it is.
Oh.
So that's why it is very important, but it's actually simple concept, because people read through the definitions and all. The definitions are very complex and all, so you'll get confused. But
Oh.
strictly
Okay.
speaking, you might see this very simple,
Yeah.
right?
Yeah. I understood easily.
This is very easy actually, but the thing is, people complicated it.
Yeah.
So you understood, right? You and Zahir also.
I'm okay, Sandeep.
Yeah. So with this, actually, today I'll close this session. Degrees of freedom, I'm going to use it tomorrow with standard deviation. But for now, let's close the session. So yeah.
Sandeep, you said you'll be inviting. You'll send the invitation for the drive, right?
Yes, yes. Actually, I was I was very busy this week, but
No problem. I mean,
because tomorrow is a holiday for me and also for
okay.
you.
Yeah.
So tomorrow I'll definitely send. I remember it actually.
No, actually, the reason that I was asking is for I'll be there in part times in the evening, so till 10:30 for EST for me.
Mm-hmm.
So that's why I couldn't uh, catch up with your words and everything. I'm just doing my work and I'm just listening to the class. So sometimes when I was speaking like this, I'm looking at the screen and I'm just concentrating on it. That's why I just want to have the video recording just to
Yeah,
follow up.
the thing is, I cannot send all the videos, but I can send the first two videos.
Yeah,
I
can
already
you keep
told
it
you
in
the
the
reason,
drive?
right? Yeah,
Can
the first two videos I can send, put it in the drive. Yes.
okay. Then which would be the better thing to follow if I want to have a Can I contact you in person or like either way in this phone or?
You can contact me in the class itself if you are let's say if you are missing some of the point, like earlier also you asked, right, some that sample and population I didn't get.
Yeah, at that time I'm just doing the my work, so
Right.
I couldn't go with that. So and this standard deviation part that you said before, I just missed that one also. I'm just doing the work. I mean, like it was somewhat busy in my store, so I'm just doing and I'm just listening. So that's what happening here.
Yeah, it's a little difficult for me to send all the videos. I mean, it's impossible for me. It's not even difficult. Um, but if you have any questions, I can answer you. But definitely, I'll try to solve your problem, but not by sending you the videos.
I understood what.
Yeah,
That's what actually. That's the
because
reason only. I mean, on Monday I would be free. I mean, on Monday I would be free.
If I send you the videos, it will be sold out in 5 minutes. I'm not talking about the quality that I teach. I'm talking about the way that I teach is nowhere. It's
I understand, but
I'm not going to bluff on this. The reason is it's very easy to sell off these things. Yeah.
Yeah, I've been in this, not in the market, but I know how this goes on.
Yeah, people will sell off this in a DVD. They'll put it in a DVD and sell off this for $10, and it's a waste of my effort. So I'm putting a lot of effort. Every day, even though I teach this regularly, but every day I will. Before teaching, I'll prepare for 1 hour at least in the evening of my time. So, because I put a lot of effort, I don't want it to get wasted. So that's it. Yeah.
Yeah. Can you give me some time after the class? At least if I miss something, I can ask and get clarified from that.
I can do it on weekends, not on the weekdays.
Yeah, no problem. On weekends, it's no problem. I'll just note it down which I was missed on the in the week.
Yeah.
If I was missed, so that I can ask you on the weekday. I mean weekends.
Yeah.
Sorry.
Yeah. But again, even on the weekends, I will be a little busy. But I'll try to make sure some time I can give it for you. But how much time I cannot really promise.
No problem. Just give me a brief description that I can understand.
Sure.
That would be fine. Just the concept with a small example. If you give with this example directly, I can understand. No need of saying the definition or something else. If you say some standard deviation, if you give direct example and if you say like this, it goes on, then that would be fine for me.
Like you see here, I will try to start with an example only. I don't even remember all the what is it? All the definitions. None of the definitions I remember. So I only give in a plain English so that everyone can understand.
Yeah, that's what actually.
Yeah.
Okay. Thank you.
Yeah, but thing is, going forward, the course will become very intensive. This is what I'm going to warn you. Because data science is not very simple topic. I'm trying to make it simple, but it won't be very simple even if I tell. So it's better you try to concentrate somehow. That's what I would suggest, because after 1 week, within 1 week you'll be covering so much of things, because now I'm covering basics. I'm going slow. Once you get into some subject, even if I go slow, you'll be feeling it is fast.
Okay.
So that's how it is. So try to follow up in the classes itself.
Yeah.
Okay.
Okay.
Zahir, any questions from your side?
Just one curiosity. I mean, after we discussed the descriptive, we immediately went into degrees of freedom.
This is part of the descriptive statistics.
Oh.
I'll cover that.
Oh.
This will be used in your standard deviation. I have not completed the standard deviation.
Oh, okay. No. That was just curious about it.
Yeah, no, I didn't close the descriptive statistics, neither standard deviation.
Okay.
Okay. Okay, then we'll catch up on Saturday your time,
Sure.
8:30. Okay.
Thanks.
Okay. Thank you. Bye.
Thank you, Sunny. Bye.